Hi! Have you ever wondered what a rational inequality is? Well, you've come to the right video. I am Jeinz, aka your Dora for this video, and we're going to learn what and how to solve rational inequalities. Welcome to the Great Inequality Adventure with Jeinz, aka your Dora. Can you see what's on the screen? Let's read what's on the screen. What is a rational inequality? A rational inequality is an equality that involves a rational expression, a fraction with polynomials in the numerator and the denominator. You solve it by finding the values that make the expressions true while making sure that the denominator is not zero. Next, we have the signs. We'll use this later when we solve. We have not equal, equal, less than or equal, less than, greater than or equal, and greater than. Next, we have brackets and circle with shade. We use that if the number is included. We also have parentheses and a circle with no shade. We'll use that if the number is excluded. Do you want to know a secret? The secret is, if the sign of inequality is less than or equal or greater than or equal, then there will always be an included and excluded. To determine which one is which, if the critical value that you solve is from the denominator, then it's excluded. You will use parentheses and the circle with no shade. But if the critical value that you solve is from the numerator, then it's included. You will use brackets and circle with shape. I found the map! What does the map contains? It has 5 stations. Station 1 is the first equation, Station 2 is the second equation, Station 3, third equation, Station 4, fourth equation, and Station 5, the last part, the fifth equation. Let's all solve it. The equation in the first station is x squared minus 4 over x minus 1 is greater than or equal to 0. Let's solve it. This is our first equation. X squared minus 4 over x minus 1 is greater than or equal to 0. Since the numerator is factorable, let's first factor it. Factor of x squared is x times x. Since it's negative, 1 is positive, 1 is negative. Factors of 4 is 2 times 2 over x minus 1 is greater than or equal to 0. Now, let's get the critical values. When we say critical values, it's the values of x. So, x plus 2 is equal to 0, x minus 2 is equal to 0, and x minus 1 is equal to 0. We're just going to transpose the numbers on the right side and change their signs. So x plus 2 will become x is equal to negative 2. X minus 2, it will become x is equal to positive 2. And x minus 1 will become x is equal to positive 1. Now, those numbers, we're going to plot it in the number line. There are 3 numbers, negative 2, positive 1, positive 2. Now, let's determine which one is included and which number is excluded. Since these two came from the numerator, it's included. So we're going to plot it as circle with shade, same as positive 2. But x is equal to positive 1, it's from the denominator. That means that it's excluded. Just circle. Now, we're going to determine the ordered pairs. This one is negative infinite. This one is positive infinite. First pair is negative infinite, and since negative 2 is included, it's going to be bracket. Next is negative 2 included and positive 1 excluded. And positive 1 excluded, positive 2 included. And then bracket positive 2, then positive infinite. Infinite will always use parentheses. Now, between those ordered pairs, we're going to choose numbers in between those numbers. So, let's think of a number between negative infinite and negative 2. Let's choose negative 3. So, that negative 3, we're going to change the x on the equation with negative 3 to see if it's true or false. So it will become negative 3 squared minus 4 over neg- negative 3 minus 1 is greater than or equal to 0. Negative 3 squared is equal to 9 minus 4. Then negative 3 minus 1 is negative 4. Greater than or equal to 0. 9 minus 4 is equal to 5 and negative 4. Since 1 is positive and 1 is negative, it will become negative. And negative number is not greater than or equal to 0. Therefore, it's false. Now, the next pair. Negative 2 and positive 1. Let's think of a number in between them. Let's choose 0. We'll change the x into 0. So 0 squared minus 4 over 0 minus 1 is greater than or equal to 0. Let's cancel this out and we're left with negative 4 over negative 1. Since they're both negative, it will become positive, and 4 over 1 is 4. 4 is greater than 0, so it's true. The next pair, positive 1 and positive 2. Let's choose 1.5. So 1.5 squared minus 4 over 1.5 minus 1 is greater than or equal to 0. 1.5 squared is 2.25 minus 4 over 1.5 minus 1 is 0.5 greater than or equal to 0. 2.25 minus 4 is negative 1.75 over 0.5 greater than or equal to 0. Since one is negative and one is positive, it's negative, and negative number is not greater than 0. So it's false. Now, let's get to the last pair. Positive 2 and positive infinite. Let's choose positive 3. So 3 squared minus 4 over 3 minus 1 is greater than or equal to 0. 3 squared is equal to 9 minus 4 over 3 minus 1 is 2 greater than or equal to 0. 9 minus 4 is 5 over 2, and 5 over 2 is positive number, and the positive number is greater than 0, so it's true. Now, let's see what is all the pairs that became true. We have negative 2, positive 1, and positive 2 and positive infinite. So our interval notation is negative 2, positive 1, union 2, positive 2, and positive infinite. There we have it. Hmm, is our answer correct? Let's see. It's correct. Let's proceed to the next equation. Station number 2 coming up. But wait, do you know how to read our answer? Our answer is read as from negative 2 inclusive to positive 1 exclusive, union to positive 2 inclusive to positive infinite. That's how you read our answer. Let's go to station number 2. Our next equation is x minus 2 over x plus 3 is less than or equal to 1. Why does it have a number on the right side? How do we solve it? It was just 0. Our next equation is x minus 2 over x plus 3 is less than or equal to 1. What about this? What's the first step? Our first step is to transpose positive 1 onto the left side. Therefore, it will become x minus 2 over x plus 3 minus 1 less than or equal to 0. And to solve this, we're going to get the LCD, which is x plus 3. And x plus 3 divided by x plus 3 is 1 times x minus 2. So 1 times x minus 2 is x minus 2. And x plus 3 divided by 1 is x plus 3 times 1 is x plus 3. So minus x plus 3. Our next step is to distribute the negative sign to x plus 3. So x minus 2, negative, positive, so negative x, negative, positive is negative 3 over x plus 3 is less than or equal to 0. Next is we're going to combine like terms. So x minus x is cancelled, and negative 2 minus 3 is negative 5. We have a new equation, and we'll use this. We're going to get the critical value. Since there's only 1 with an x, So that's the only one that we're going to get the critical value. So x plus 3 is equal to 0 will become x is equal to negative 3. Since there's no x in numerator, there won't be any critical values from the numerator. So we're going to plot negative 3 on the number line. Since it's from the denominator and our inequality sign has an equal, we have to determine which one is included or excluded. But we only have one critical value, and that is negative 3, and negative 3 is from the denominator. Therefore, negative 3 is excluded. Then we get the ordered pair. Negative infinite, positive infinite, negative infinite, negative 3, and negative 3, positive infinite. Now, let's think of a number in between those ordered pairs. Let's solve first for negative infinite and negative 3. Let's choose negative 4. So let's change this equation. Let's change the x of that equation into negative 4. So negative 5 over negative 4 plus 3 is less than or equal to 0. So negative 5, negative 4 plus 3 is negative 1. Since both is negative, it will become positive, and 5 divided by 1 is 5. Positive number is not less than 0, so it's false. And next we have the ordered pair negative 3 and positive infinite. Let's choose the easiest, 0. So 0, negative 5, 0 plus 3 is less than or equal to 0. So negative 5 and positive 3. One is negative, one is positive, and it will become negative. And the negative number is less than 0. So it's true. Therefore, our interval notation or our final answer is negative 3 and positive infinite. There you go. Let's see if our answer is correct. It's correct. Our answer is read as negative 3 exclusive to positive infinite. Let's proceed to the next equation. The equation in station number 3 is 2x minus 5 over x squared minus 4 is less than 0. What about this? How can we solve this? It doesn't have a equal on the inequality sign. How do we solve it? Now we're on the third equation. 2x minus 5 over x squared minus 4 is less than 0. What can you say about this equation? The inequality sign has no equal. Therefore, there won't be any included numbers. So first, what do? Let's factor out the x squared minus 4 first, since it's factorable. So 2x minus 5 over factor of x squared is x times x It's negative, so positive, negative. Factors of 4 is 2 times 2, less than 0. So let's get the critical values. 2x minus 5 is equal to 0. X plus 2 is equal to 0. X minus 2 is equal to 0. So 2x is equal to 5. Divide both sides by 2 to get x. X now is equal to 5 over 2, which is also 2.5. X plus 2 is going to be x is equal to negative 2, and x minus 2 is x is equal to positive 2. Now, let's plot this on the number line. We have three numbers, negative 2, positive 2, and positive 2.5. Since they're all excluded, we'll just use circles. Now let's get the ordered pairs. Negative infinite, positive infinite. So first ordered pair is negative infinite and negative 2. Next, negative 2, positive 2. Positive 2, positive 2.5. Positive 2.5 and positive infinite. Now, let's choose a number in between those pairs. First is negative infinite and negative 2. Let's choose negative 3. So let's change the x on the equation to negative 3. 2 times negative 3 minus 5 over negative 3 squared minus 4 is less than 0. Now, what is 2 times negative 3? It's negative 6 minus 5. Negative 3 squared is 9 minus 4 less than 0. Negative 6 minus 5 is negative 11 over 9 minus 4 is 5 less than 0. One is negative and one is positive. That means it's negative, and the negative number is less than 0. So it's true. Next ordered pair. Negative 2, positive 2. Let's choose the easiest. 0. So 2 times 0 minus 5 over 0 squared minus 4 is less than 0. Let's cancel out 2 times 0 and 0 squared. And we're left with negative 5 over negative 4. Both are negative, so it will become positive, and 5 over 4. A positive number is not less than 0, so it's false. Next, we have positive 2, positive 2.5. Let's choose the number 2.25. So 2 times 2.25 times, minus 5 over 2.25 squared minus 4 is less than 0. So 2 times 2.25 is 4.5 minus 5. 2.25 squared is 5.06 minus 4 less than 0. 4.5 minus 5 is equal to negative 0.5. And 5.06 minus 4 is equal to 1.06 less than 0. 1 is negative and 1 is positive, so that means it's negative. And the negative number is less than 0, so it's true. And the last ordered pair, 2.5 and positive infinite. Let's choose positive 3. So 2 times positive 3 minus 5 over 3 squared minus 4 is less than 0. 2 times 3 is 6 minus 5. 3 squared is 9 minus 4 is less than 0. 6 minus 5 is equal to 1. 9 minus 4 is equal to 5. And we're left with 1 over 5. It's a positive number. And the positive number is not less than 0, so it's false. And the ordered pair that became true is negative infinite, negative 2, and 2, 2.5. Therefore, our interval notation is negative infinite, negative 2, union 2, positive 2, positive 2.5. And there you have it. Is our answer correct? Hmm, it's correct. Our answer is radius from negative infinite to negative 2 exclusive union to positive 2 to positive 5 over 2 exclusive. Let's proceed to the next equation. See you on the next station. Station number 4. Our equation for this is x plus 2 over x minus 3 is greater than 1. Let's solve it. This is our fourth equation. X plus 2 over x minus 3 is greater than 1. Since there's a number on the right side, we're going to transpose it to the left side. Or x plus 2 over x minus 3 minus 1 is greater than 0. What is the LCD? The LCD is x minus 3. X minus 3 divided by x minus 3 is 1 times x plus 2 is x plus 2. X plus 3 divided by 1 is x minus 3 times 1 is negative x minus 3. Now, we're going to distribute the negative sign to x minus 3. So, x plus 2, negative x, negative negative, become positive 3 over x minus 3 is greater than 0. So, we combine like terms. This will cancel out. We're left with 2 plus 3, which is 5 over x minus 3. It's greater than 0. Now, let's get the critical values. Since there's no x on the numerator, we'll only just have one critical value, which is from the denominator. X minus 3 is equal to 0. X will become positive 3. Now, let's plot it. Since there's no equal sign in the inequality sign, there won't be any included numbers. Positive 3, so we'll just use circle. Now let's get the ordered pair. negative infinite, positive infinite. So first pair is negative infinite, positive 3, and positive 3, positive infinite. First, we'll have the first ordered pair, which is negative infinite, positive 3. Let's choose the easiest, x is equal to 0. Now let's change the x of this equation into 0. So 5 over 0 minus 3 is greater than 0. This will cancel out and we're left with 5 over negative 3. One positive and one negative means negative. And a negative number is not greater than 0, so it's false. Now, let's get the second ordered pair, which is 3, positive, infinite. Let's choose 4. So, 5 over 4 minus 3 is greater than 0. 5 over 4 minus 3 is 1. And let's simplify it. 5 divided by 1 is 5, greater than 0. Positive number is greater than 0, so true. And we're done. What's our interval notation? Our interval notation is 3, positive, infinite. And there you have it. Let's see if our answer is correct. It's correct! Can you read our answer? Why don't you try it? Come on. That's right. Our answer is radius from positive 3 exclusive to positive infinite. Now, let's proceed to the last station. Station 5. This is our last equation. X squared minus 6 over x minus 4 is greater than 0. What about this? How do we solve it? It has a trinomial numerator. Do we factor it out first? Or do we just proceed? Let's see. Let's solve it. And for our last equation, we have x squared minus x minus 6 over x minus 4 is greater than 0. Now, let's first factor the numerator since it's factorable. What's the factor of this is x minus 3 and x plus 2 over x minus 4 is greater than 0. So let's get the critical values. Since there's no equal on the inequality signs, there will be no included critical values. So x minus 3 is equal to 0, x plus 2 is equal to 0, and x minus 4 is equal to 0. X is going to be positive 3, negative 2, and positive 4. Now let's plot it on the number line. We have three numbers and they're all excluded: negative 2, positive 3, and positive 4. We'll use circles to plot them. Now let's get the ordered pair. Negative infinite, positive infinite. First ordered pair is negative infinite, negative 2. Negative 2, positive 3. Positive 3, positive 4. And positive 4, positive infinite. Next, we're going to choose a number in between those ordered pairs. First, we have negative infinite, negative 2. Let's choose negative 3. So we're going to change the x on the equation into negative 3. We'll have negative 3 squared minus negative 3 minus 6 over negative 3 minus 4 is greater than 0. Negative 3 squared is 9. Negative negative is positive. Minus 6. Negative 3 minus 4 is negative 7. It's greater than 0. 9 plus 3 is 12. Minus 6 is 6 over negative 7. One positive, one negative, it means negative. And a negative number is not greater than 0. So it's false. Next we have negative 2, positive 3, and we'll use the easiest 0. So 0 squared minus 0 minus 6 over 0 minus 4 is greater than 0. So cancel, cancel, cancel. We're left with negative 6 over negative 4. Since they're both negative, it will become positive, and it can be also simplified. They're both divisible by 2, so 6 divided by 2 is 3, and 4 divided by 2 is 2, greater than 0. It's a positive number, so it's greater than 0. True. Next, we have positive 3, positive 4. Let's choose 3.5. So 3.5 squared minus 3.5 minus 6 over 3.5 minus 4 is greater than 0. So 3.5 squared is equal to 12.25 minus 3.5 minus 6 over 3.5 minus 4 is equal to negative 0.5. It's greater than 0. And 12.25 minus 3.5 minus 6 is equal to 2.7 over negative 0.5. One is positive and one is negative. Therefore, it's not true. It's false. And our last one is for positive infinite. Let's choose 5. So 5 squared minus 5 minus 6 over 5 minus 4. 5 squared is 25 minus 5 minus 6. 5 minus 4 is 1. 25 minus 5 is 20. Minus 6 is 14 over 1 14 divided by 1 is 14. Greater than 0. It's a positive number, so it's greater than 0. So it's true. And now for our interval notation, it's negative 2, 3, union 2, 4, positive infinite. And there you have it. Let's see if our answer on the last equation is correct. It's correct. Can you read our answer? I'll give you time. That's right. Our answer is from negative 2 to positive 3 exclusive union to positive 4 exclusive to positive infinite. We finished. Congratulations! Thank you for making it till the end. I hope you learned something from me about rational inequalities. I hope I have shared some of my knowledge to you about it. Thank you for listening. Again, I am Jeinz Danielle Andrada, and always remember, be blessed and be a blessing to everyone. Thank you.